Link test. Remember lock status RSSI loopback allows testing the IDU and OMU. Everything I talked about, I was kind of pointing to Giga Plus, but you do that same loopback testing on the Apex Plus. Okay, it still has a cable going between the IDU and the ODU. Okay, we just call the IDU an OMU, an outdoor modem unit. Okay, so we still check the signal there. It's possible for that cable to get damaged, especially if you think that cable's a handle. It's not a handle. There's a handle on the top, not on the bottom. Okay. We talked the other day, you could also use loopback for TDM testing. Okay. In that case, you would not use the auto loopback, and you would purposely set it to loopback IF or loopback DIG, and leave it there while you're doing your T1 testing. Okay, diagnostic, I told you yesterday, does check some hardware functions. I didn't actually run it, but if you run it from CLI, you'll get a check switch, pass, check 5, pass, check this, pass. Okay. The real purpose is it creates a binary file which you can transfer to us, which has all sorts of crazy diagnostic stuff in it. We very rarely, once in my life, have I ever asked for one of these. We very rarely do it because it's a pain for you to transfer the file and send it to us, and it's a pain for us to decode it and everything else. But we have it should we need it. 9 times out of 10, really, if you're having that bad of a problem, I'm just going to ask you for remote access, and that tends to be the easiest thing to do. Speaking of which, if you can plan your network for some level of remote access, it might make your life easier someday. Might. Target RSSI on the old Gigas, this would definitely do that. Doesn't really do too much now. Poor cable, IF cable issue. I've been standing there for too long. IF cable issue would be a very likely cause of bad MSE, especially, well, no. A cable issue can show up on both sides.
Going back to that target RSSI on the Gigas, that actually has an effect on the link on the Gigas.
The Gigas, yeah, it does.
We still got some of those, and I know we had, so it doesn't apply.
With anything current, the target RSSI is only used for ATPC.
Okay.
On the Gigas, the target RSSI was used to control all sorts of crazy stuff. ODUR, the AGC was used in it. There was a figure out the issue. Okay, so IF cable issue, that can show up as bad MSE both directions. Okay, so you can have it both sides bad. There's no way necessarily to say which side, other than that loopback IF might point to one side or the other having bad MSE. Okay, so if you have bad MSE and your RSSI and all that is on where you're supposed to be, then I would certainly start going and looking at doing those loopback tests to rule out hardware. Finally, interference is a possible case with MSE. Right? These are, well, most of them are licensed links, but people are human. They swap radios, put them in the wrong spots. They put their transmit powers too high. They do all sorts of other stupid things. They don't align their links. I'm not trying to look at anybody in particular, sorry. They don't align their links, and that causes you interference because they didn't align their link. Okay, so you do need to rule that out. Best way to rule that out, reboot one side, check what the RSSI is on the other side. Okay, or also off. That requires potentially more work. You should see a negative 90 RSSI with the other side's op mode off. If you see more than negative 90, you may very well have interference. Okay. That's it for MSE. If you have low RSSI, I really didn't harp on the alignment much this time. I normally harp on it a lot more. John can vouch for that. Alignment. If your RSSI is symmetrically low on both sides, I don't want to say something I regret. It's your alignment. Okay? Now that could include polarization and whatever else, but your alignment. If it was negative 40 yesterday, and now both sides are negative 60, I wish I could say 100% of the time. 99% of the time, it's alignment. Okay. It's very unlikely to have two transmitters or two receivers on opposite ends of a link, because remember, these things aren't even at the same site, so it's not like they both got hit by lightning. They're 10 miles or 30 miles or 60 miles apart. Both have the same failure? Not very likely.
Question.
Alignment.
If it was alignment though, one side would be off, right?
Both sides would be off. If I move, so if I'm at negative 40 right now, and I move this antenna, which I can't move. If I could move the antenna, I'm going to immediately see the arc side drop on both sides because they're out of alignment.
Oh, I thought if that one was pointing at it, even though it's at the wrong angle, the signal would still be received.
Because my beam width is so small, even if I turn this one, I can't see that one anymore. Even though that one's aligned, I can't see it because I'm shooting over. I mean, my laser.
On a 5 gig link, that's true.
I'm shooting over
So
here.
one, you'll see.
Something a little wider beam.
Yeah, you'll see one better.
Yeah,
than
if
the
you've got a 15-degree beam width or something, then yeah, it totally can be different. But you're talking about, I mean, you're literally talking about this laser pointer. Okay.
It's like an 80 gig.
1 degree, 2 degree beam widths in these antennas. Polarization again. They've got to match for license. They've got to be opposite for straddling. Old Apex and Giga owners, I'm so sorry. I don't know what people were thinking back then. This waveguide interface thing was so confusing. Trango engineers couldn't even figure it out. Okay. The waveguide's got to line up inside. Okay. You've got that little funny piece you had to put on the Apex or the Giga ODU, and there was an opportunity for you to put that on 90 degrees different. Then you could put the radio on 90 degrees different. You could just mess the whole thing up. Trango employees couldn't figure the thing out. Fortunately, you don't do it anymore. So check that waveguide if you have old Apex and Gigas. Especially on Giga, that target RSSI could be your low RSSI. I was going to say I promise this will be the last time I harp on it, but I doubt it will. Number one source of frustration, again, is the antenna alignment. Remember, again, very, very low, very, very small beam widths in these things. Very small adjustments can create huge changes in RSSI. Do not be afraid to go past the point. Okay, I was talking to a guy the other day that said, man, you really didn't stress enough to me how far past I needed to go. He said, you were telling me like quarter turns. I needed to go 7 turns. The guy was like out here on a side lobe, okay, and he's thinking that's all he could get. And so he had to go like 7 turns of the bolt before he got on the center. Okay? Don't be afraid to go past it. Go way past it.
Is that his first radio link?
Yes. If you found it once, you can find it again. Tips I've heard from some people, and you guys probably have more than I do because you align and install more links than I do. Mark the bolt or whatever, count how many turns you go past it, so you can always come back to it. Okay? So keep that in mind. Remember, you've got to deal with this in 3 dimensions or 2 dimensions. Okay, this way, and this way, this way. All right. Again, a lot of this stuff is repetitive. Loop back, we've talked about. Any questions on it? Going once, going twice. Sig level. Okay, IBU RSSI, or in the case of an Apex Plus, OMU RSSI. Okay. The ODU maintains a constant output of about -10. If you have a very short cable, like an Apex Plus, I would expect to see the IBU RSSI about -10. If you have 1,000 feet of cable, I'd expect to see it about -25. If you call me up with Apex Plus, and I pull up this IDU RSSI, and it says that it's -25, I'm going to ask you one time, did you pull the two units apart? You're going to say no. Then I'm going to ask, did you use the IF cable as a handle? Well, it might have fallen on it. Okay. This will tell you lots of times if you have a severe issue with your cable between the IDU and the OMU, or the IDU and the ODU. Okay. That should match within 2 dB or so of those numbers. Okay, if you log into the radio and you look at sig level and you see normalized MSC of -60, you're like, yeah, this is awesome. I've got better signal than he said I could get. He said -38 is the best I could get, and I got -60. No. Put a little decimal point there, okay? On there too. It's expressed in tenths. So if you see -60, you really see -6. Okay. You can read what this says. I won't bore you because you won't remember it anyways. But that can point you in a direction if one's better or worse than the other. If you type sig level in the support portal, you'll find all this when you need it. Okay. LDPC decoder stress. This measures how hard our forward error correction engine is working. It should be 0. It could occasionally burst into the hundreds or thousands, and that is perfectly normal for it to correct multipath and other issues that come up. If it is consistently up in the high hundreds of thousands range, you probably have some other kind of an issue going on. And 9 times out of 10, you're going to see it in the MSC too. Your MSC is going to be lower than it really should be for your RSSI. Your MSC might be okay. I mean, it might be like 32, but you have a signal of like 40, and the MSC really should be 36 or something like that. Okay, you'll see it in this LDPC decoder stress. External AGC, so that's the correct signal level. Okay, carrier offset. This is expressed in hertz, so don't get crazy about how big of a number it looks like. You're allowed to be, for like 10 gigahertz, you're allowed to be off 50 kilohertz either way. Okay, so for 20 gigahertz or 18 gigahertz, it would be like 100 kilohertz either way. What we really want to look at here is if this number is fluctuating wildly. Okay, 22,000 to 21,000 to 23,000, that's not fluctuating wildly. That's pretty good. If I see -22, and then the next time I run sig level, a second later, I see positive 40,000, and then I see -10,000, and then I see positive 20,000, and then negative 40,000, that's fluctuating wildly. Chances are a PLL is either unlocking or about to unlock. Chances are there's some kind of hardware failure going on at that point. Okay. When I see that, it's typically the beginning stages of a PLL unlock. If you type the speed command into the CLI, you'll get this symbol rate or sim rate. The RX sim rate in sig level should match what you see when you type the speed command. Okay. If it doesn't match, then you probably have a physical problem with the IDU or the ODU. This is my favorite sig level command. And you can actually monitor this via, well, you can monitor the second one, I think. I don't know if you can do the first one. Via SNMP now. Okay. Block counter. This is counting the number of blocks. Call them packets or call them frames to put it into something you're used to hearing. Transferred across the radio link. Since the last time it was cleared. Okay, simple. Great. Nothing special. Uncorrected blocks. This is blocks that came across that had an issue and we could not correct it. Again, this is a packet or a frame that came across and we dropped it. Or it was so badly damaged because of multipath or something we could not correct it. It will show up here, I promise. If you call me up and tell me you're dropping traffic, and status port doesn't show it, and the uncorrected blocks is 0, I'm going to call you a liar. Okay? I have never seen packets dropped that were not reported by Uncorrected Blocks. Okay. Now, all of you are logging into your radios right now and checking your Uncorrected Blocks. You're going to see a number there. I promise you're going to see a number. Unless you just cleared your counters. When the link first comes up, there will be a time period at which it was establishing the link, and there will be uncorrected blocks from that link establishment. So, you either need to clear this every time you restart the link, or you change the speed, because if you change the speed, or you op mode off, or you test loop back, or you do anything that breaks the link for a fraction of a second, that's going to cause an uncorrected block. So, either clear it every time you do that, or monitor it via SNMP, and you tell PRTG to email you every time it changes. That's what I do. Okay? If I had to pick one thing in my life to monitor on the radio, I think it would probably be uncorrected blocks and not the link lock. Okay? The only difference is uncorrected blocks probably wouldn't tell you anything until the link was locked, as opposed to link lock would tell you when it became unlocked. Okay? Clear that by using status clear or the Ethernet counters, clear counters button. Okay. It will show up there. In the most recent firmware release for Apex Plus and Giga Plus, you can monitor this via SNMP. You could monitor it before that, but don't. Use the most recent release. LDPC average is just the average of what the other one was. The rest of these things you can read. Those of you with gigas that are trying to type SIG level, you're getting unknown command. Yes, it doesn't work. You'll get different information based on the software you're running, based on the hardware, all that stuff. So some of these things may vary based on what you have, okay? You may also see some power sensors, okay? TX power alarm, PA on off, da 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 da. The one that's confusing to me, probably confusing to you, is the PA on-off alarm. If you just ignore the word alarm, it makes sense. PA is the power amp. You want the power amp on. So PA alarm on is a good thing. I always thought that was bad. Okay. It will show you your transmit power actual. Depends on your ODU model. It's either going to be in English or it's going to be in some funny hex, which is double the value of what it really is. But it should be close. We can figure out what it's supposed to be. Receive power actual should be your RSSI. Channel test, telemetry debug should both pass if you see them. We are like 3 or 4 slides away from a break. I know you guys are getting